All right, so the first thing that we're going to be doing is we're going to be doing the Project 5 mood cue. Okay, if you go to the Learn, you change it to Circuits, and then you hit Projects and Show All, you'll see a handful of projects down below. I kind of like this mood cue first. It gets us into a couple different parts that we haven't worked with yet, which are capacitors and servos. Okay. We might jump back and do probably this digital spaceship interface one day, and then come down and do like the digital hourglass. But what I'm thinking for the next handful of weeks is we'll do one of these bigger projects. We'll start it on Monday, do the coding on Tuesday, show it off Wednesday, or do the build on Wednesday, Tuesday, and then do the code on Wednesday, show it off. And then Thursday, Friday will kind of be open days for us on Zoom. Okay? So we're in here. We're over at the Mute Queue Project 5. Okay? I've already gone through part of it. Okay? So we're going to go into here. I'm going to hit reset so I can get back to where we are starting at. Yes. Okay. So what this first area is its introduction. It's introducing us to what these parts are. Okay, so we know our Arduino board, we know our breadboard. Okay, so in this project we can see that we are mostly powering stuff for the 5-volt and the ground. Okay, and we're going to be connecting the digital pin 9 is going to be just telling us an on or off pulses to the servo, and just kind of telling it, hey, we're on. Okay, now we're off. Okay, and then the analog out, we're going to see a voltage or changing voltage coming out. So we can see our schematic here. Okay, so this is a 100 UF capacitor right here added on. This is our potentiometer resistor. Okay, what those will do is those take the two inputs, and then it tries to balance in between them to where they equal out at 10,000. Okay, 10,000 ohms. Okay. So if we're faded towards one side and one side's reading 2,000, that means the other side has to be reading 8,000, and it adjusts from there. Okay. So we have a little bit of a capacitor there to increase that. Okay. And then we have a capacitor over here next to the servo to help maintain power there. We can see via the schematic that we're coming out on the 5-volt, so 5-volt comes into the potentiometer and the capacitor. We also have the 5-volt coming out and coming into the servo and the capacitor. And then we have signal from 9, signal out from analog. Okay. And then this is our negative coming back into our ground. Okay. So the next thing that it wants us to look at is the potentiometer, a servo motor and servo motor arm, and then two 100 UF electrolyte capacitors, and of course your Arduino and Uno board. Okay, so we have our Arduino Uno and our breadboard. Okay, so this is where we might need to update our steps instead of just utilizing the basic, because we do have a capacitor here. It is a capacitor of 100 NF. So we need 100 UF, okay? But then we'll look at this and we're like, but it's not the same capacitor. Would this work? This would technically work, okay? But what it's getting us to use is a different type of capacitor. Where we'll find that is if we go to the upper right-hand corner, we'll see components, basic. We can click that down and go all. Now we'll see a polarized capacitor. We can set that to 100 UF. In the voltage range, we can leave that at 16 volts. Okay. We know that we'll need 2 of those. Okay, I'm just using Control C and Control V to copy and paste. Okay. We'll need a potentiometer. And I'm just scrolling down to figure out what else we'll need. We'll need a servo. Okay, if you don't want to scroll through it, but you know the names, like we could see servo motor. Okay, we can go servo, and it'll separate it out for us. Okay, we could do either the micro servos. Either of those would work. Okay. Just notice that the plugs will have the signal, which is usually shown by a white cable, power positive coming into the servo, and then ground negative leaving the servo. Okay? So these are all the parts that we'll actually need for this. Okay? So this is now talking about how this potentiometer works. Okay? So in the pot, in your Arduino kit is a 10K kilo ohm. So we need to set that up. So that's a 10 kilo ohm. So the little k. Okay, and the ohm. Okay. That means that resistance 1 and resistance 2 is always equal to 10,000 ohms. Okay. So if this fades one direction towards the other, it'll always total out to 10,000 ohms. Okay. If it's directly upright and center, that means that there's no fade left or right. That means both of those must equal 5,000 ohms. Which means if we're looking at the calculation, so it's always easy to calculate. So we have R1 divided by 10,000 times 5 volts is always how we reach our ohms. Okay, so if we look at this, if the knob is sitting right in the center, R1 equals R2 with a 5 volt power source, the output voltage will be the source cut in half, 2.5 volts. Okay, and that is dependent on whether or not we have two different voltages coming in. If we're using one as a ground to return, so that would always be flowing out, then yes. Okay, so this is where we're getting to. So suppose we have turned the knob partially clockwise towards R1. So R1 equals 8,000 and R2 equals 2,000. So the output voltage will be 8 to 10 of the total, or full volt, 4 volts. So 8/10. So we'd take that and we'd go that out. Okay? Okay. So our next step is going to be looking at the servo. So similar way you use the pulses to PMW to light an LED, the color mixing lamp. So that was the previous project. We didn't do that. Okay. It's the same ways for us to set up angles for this in here. So the pulse always comes at the same time intervals, but with the width varies in between 1,000 and 2,000 microseconds, or 1 to 2 seconds. While it's possible to write code to generate these pulses, the Arduino software comes with a command library that allows you to easily control the monitor. So how we're going to do this, so find the servo motor in the components menu. All components have to, okay. So now what this is doing is it's going to show us how to pull in what are known as libraries. Okay, so you can see up here, this is still an older screenshot. Okay. But what we're going to do is we're going to go to our code, okay, and you'll see 3 buttons in the middle. You'll see a debugger, you'll see libraries, which is the one we want, and we'll actually see download code. And the reason why you'll see download code is we can actually code everything in here, hit download, and it'll create an Arduino file for us to utilize within the other program, within our base program of Arduino, which we'll be able to then see and use our build tomorrow. Okay, so we're going to go to libraries, and we're going to find the servo, so controlling servo motor. Okay, What that means is it's going to include the servo.h file or library, which has a bunch of built-in code structures to help the servo move around and do stuff. Okay. Okay. And that's the first part. So that's the introduction. So now we're going to go to setting up the circuit. Okay. Now you'll notice it brings us to a brand new page. So the pieces that we pulled out, we'll have to pull those out again. Okay. So we know we'll need 2 of those. Okay. We'll need the potentiometer. And we'll need the servo. Okay. So now what we're going to work on is we're going to work on creating this. Okay. Now I know it's utilizing some different looking things for us. These are old versions, picture versions of this. So we don't have things that look exactly like this, but you'll see from here that we'll be able to show it pretty close. Okay. So this is 100 UF, 100. Okay. Our potentiometer was 10 kilo ohm. And our servo is fine. Okay. Okay. So the first step that it has us do is follow along with power. We've been doing the power for a while. So we should know that if we want to line up positive to positive, negative is going to be negative to ground. I'm just color coding it because I'm used to color coding based off the fact that the wires, when we actually do build this, will have a match. Okay, so we set up the 5-volt and ground. So now we're going to work on setting up the potentiometer. You'll see on here that there's a signal wire, which is the center post, is going to return back to A0. Okay, so I'm going to place this. Now we're going to check. Okay, so terminal 1, we're going to have negative. Terminal 2, we're going to go positive. And this we're going to have trace around to our A0. Okay. So now it's going to tell us like specific spots to put certain pieces for the digital pin. Okay. What it's looking at is it's basically making sure that we have our signal positive, negative, right. Okay. So I'm going to bring this up and we're going to rotate this. Okay. So we're going to bring power down. Now I could trace power up like this. Okay, I could do that. Or because we're looking at a servo, I could just bring it around. And we could go positive to positive, negative to ground. Okay. And then it's calling us to have this signal wire come over to 9. Now I'm going to change that so I don't get confused at which signal wire we're looking at. Okay. Okay, so you'll see that we need to have it with the PWM enabled. So you'll see the little tilde key next to it. So our one of them, we could have really done it in 3, 5, 6, 9, 10, and 11. We could have done that, but it's okay for right now with where we're at. So that this is talking about right here is attach the servo Arduino kit. So if we have a kit, servos usually come with this specific type of plug. Okay, and usually you have to have a bridging piece in order to actually plug it into the breadboard, or you can also stick wires into each pin and then plug those wires in. Both work. Okay. So now what we're looking at doing is making sure our capacitors are in line with our power. Okay. Now what we might notice is we can't run power like this. Okay. So now we need to make sure our capacitor for both sides are set up right. So we'll see this is our negative. So for this one, we can just feed that across and go negative. And this can come across for positive. Okay. But how are we supposed to do this? Well, we'll need to update. So we can come up and go negative here. You go positive to here. And you'll see that that matches up positive and negative over there. And what we're going to do is we're just going to grab this endpoint and drop it in to a point over there. And we're going to switch this one up to swing up above, and this one can stay there. Okay, if we wanted to clean it up just a little bit more, we could swing this up above and move that port up. Okay, and then we could actually then move this down, and that looks pretty clean. Are the instructions on this assignment? Yes, there are. There are full instructions on here, so if you wanted to continue on, you do not need to follow the video. The video is there for people who need to do it at a later date or are wanting to join us late. These will be posted onto that YouTube channel that I've been posting to for the other ones too. Okay, so our capacitors are in line. So now we're ready to start writing the code. Okay, not a problem. Okay, so what we're going to be looking at right here is our whole image is going to change. Okay, we've seen the other parts of this all together in the previous ones, and it's going to jump us to the existing board that they have. Okay, so once again, we don't have access to these parts. Okay, but they can still post them. Okay. So we're looking at this. So this is our next step. So this is the same setup from previously. Supplying extra power through the positive, through the negative. The only part that I don't like on here that they didn't change was this wire should be reading our negative. Okay. And then our signal wire, change that back to our green, and this can go back to orange. Okay. So our next big step is we want to start coding. Okay, so we want to include the library. We include the library by clicking our libraries key and going servo. Okay, we got that library included. Define variables and constants. Okay, so my servo is going to be a constant. Servo. Servo my. So this set of code is going to be very specific. If you see it uppercased, it has to be uppercased. If you see it lowercase, it has to be lowercase. Okay. Now you can also go and copy the code in. Okay, also works. Okay. So right here, what it's getting into is it's calling out an int constant pot pin, and then it's equal A1 int pot val, and then int angle. So this is how it's going to have the variables in order to connect and define what the angle, what the variable, and then what the value is from that reading from the potentiometer. Okay. Okay. So now we're getting into our void setup, which is this setup function right here. Typically within Arduino, the void setup and the void loop, you wouldn't see them like this. You'd actually see them in there. And typically most people would tell you never delete them. Now the curly Q bracket is going to be a shift, and then it's the bracket right above your apostrophe. Now what this is going to do is this is going to define the setup areas in between those two brackets. So what we need to include in there is my servo dot attach. And what we're going to do is we are going to attach it to port 9. And so what that's signaling is that's going to get information from there and tell it to work or not. Activate, turn on, set up, what have you. Okay. And the last part that we're going to put in is a serial.begin. And what the serial.begin does is it lets us utilize the serial monitor there. And the number that follows, don't change it. There's no real reason to change it. Okay. But what that's going to do is that's to the baud level. And so that's kind of it's a code that it's looking at. Okay. So now we're going to get into the void loop. Bracket, bracket. Okay, and so in here we're going to go pot value, or pot val is equal to the analog read of pot bin. And then the serial print is going to print out what our information is. So it's going to go, we're going to leave quote, quote, okay. So when I like separating out our major content areas in between, this would also be a good spot to take this in. So we could do a comment by doing a double / and going gets and displays pot val for us. Not a problem, Caleb. I'll get out the video comment or the video link later today. Okay. So what we're going to do is we're going to be mapping out the value for value, min, max, min out, max out. Okay. So what it's taking in is input, and then what it's outputting is out. Okay. So this is going to relate to our angle that the servo is going to be posting at. So our angle is going to equal map and our pot val, so min in, okay, So what we'll see is the minimum value that our potentiometer can do, which is 0, to our maximum value that it can go is 1023. And then for our angle, we're going to go 0 to 179. So not a full 180. Okay. So we can go maps angle from pot val. Okay. So we're going to have our next set of serial. And we're going to have this post our angle. And the print lin is going to make it so each time it does now a new line. So these previous prints would all print on the same line, and then this would come out as a new line. Okay. So now what we're going to do is we're going to take this and we're going to go writing to servo. Okay, so we're going to go my servo dot write. And then we're going to go angle. And the little delay just allows the servo and the Arduino to kind of catch up with each other, so it's not flowing as frantically as it could be. Okay, so what we're going to do is we're going to actually now be able to start the simulation, and assuming we have everything set up, it should work. Okay, so let's figure out our error. Okay, so in function void loop, expected error before numeric constant, so 23. So let's go back a couple steps and check that out. So void loop. So it's got our dual quotes, open, closed. So pot pin, okay, that's good. Serial print, that's okay, that's okay. Oh. Oh, I see where it's at. It's probably that one right there. Look at that. So now what it's doing is it's adjusting based off of this potentiometer. So we can adjust this around and it'll slowly move around. Okay. So if we were able to set that as technically 0, this should be sitting pretty close to straight out. It's a little off. But if we check to see where that's at versus the start, so we have a little bit of probably voltage offset in between. I mean, mind you, it's trying to read us as accurately as it can out there. Okay, so it's a little off center, and then but it should be straight. Okay. Okay. So we're going to continue to creating the gauge. Okay. So this is where it's actually the building part of it. Okay. So this is if when we are actually physically doing it, we'd be able to set up the gauge over here. So come in, keep out, and we can actually set that based off of how this is spun. Okay. And this is the project. So here would be my challenge is there anything else that we could add up? Could we possibly even add an LED to this? So that would be the thing to check. How would we add an LED to also then vary its light based off of how much that is good versus bad for it? Could we set up a chain of LEDs to light up based off of how much charge is going through this? Okay. So those are our next steps, and those are our next challenges at home. Okay. So those would be things, if we can look those up, we could see, could we vary that? We could go back to a couple days ago's assignment or Tinkercad project, and we could see how to utilize the potentiometer with an LED. Okay. So with that, I'm going to stop our recording. You guys have a good rest of your week. I'll see you guys possibly tomorrow during the same time. Thank you.